Tele. Hello everyone and my greetings to all my dear students. We finished the biomolecules in the last class. Now in today's class we are going to start a new chapter called surface chemistry. And surface chemistry is the fifth unit of your first part of chemistry textbook. Before I begin, let me give you an idea about what is surface chemistry. Now, surface chemistry is a branch of chemistry which comes under physical chemistry, and it deals with the phenomenon that occurs at the surface. So you will know better when I go into detail. Now, first, let me give you the outline of the topics that I'm going to cover in today's class. Those are absorption. What is absorption? Then you will have what is adsorption, and how is absorption different from adsorption? That is the difference between adsorption and adsorption. And then the types of adsorption, that is physisorption and chemisorption, and the difference between physisorption and chemisorption. And finally, the factors affecting absorption. So moving forward, absorption. Now, whenever we talk about adsorption, one of the most common example that comes to our mind is a sponge dipped in water. So a sponge dipped in water is an example of absorption because in this process, what you observe is when the sponge is dipped in water, you will see that the water starts to enter into the bulk of the sponge. The phenomenon where the particles enters into the bulk of the substance is called as adsorption. Whereas in the case of adsorption, you will see that the molecular species, it remains on the surface of the absorbent rather than entering into the bulk. So that is the difference between absorption and adsorption. In the case of absorption, the molecules enters into the bulk, whereas in the case of adsorption, the molecules remains on the surface area. When it remains on the surface area, it is called as adsorption, that is AD. Whereas in the case of absorption, when the molecules enters into the bulk, it is called as absorption, AB. So that's the main difference between adsorption and adsorption. Now let me give you the definition of absorption and adsorption. The absorption, it is the assimilation of the molecular species throughout the bulk of the solid or liquid medium. That is, it is a bulk phenomenon. Whereas in the case of adsorption, the accumulation of molecular species at the surface rather than in the bulk of a solid or liquid. That is, it is a surface phenomenon. Now let's move to the adsorption. So in this chapter, adsorption, since it being a surface phenomenon, we will be dealing more with adsorption rather than absorption. Absorption is a bulk phenomenon, that's why adsorption is our prime focus in this chapter. Now, in the process of adsorption, the two conditions need to be fulfilled for that to happen. The first one is the presence of the absorbent, and the next one is the presence of the adsorbate. So whenever absorbent and adsorbate are present, adsorption can occur. Now, what does mean by absorbent? Now, absorbent refers to the surface area of the substance on which absorption takes place, whereas the adsorbate are the molecular species which comes and sits on the surface area of the absorbent. So adsorbate are the molecules which gets adsorbed on the surface area of the absorbent. Now let me give you the definition of adsorbate and adsorbent. Now the absorption includes two components, that is the adsorbate and adsorbent. Adsorbate are the molecular species which accumulates at the surface. And the examples that I've taken is hydrogen, oxygen, and carbon monoxide, which are gaseous. Whereas in the case of absorbent, the materials on the surface of which absorption takes place is called as absorbent. And the examples that I've taken is alumina gel, charcoal, silica gel, etc. Now here you can see that the adsorbate that I've taken is gaseous, whereas in the case of adsorbent, the examples that I've taken, alumina gel, charcoal, silica gel, are all solids. So here, if we talk about the absorption of gaseous on a solid surface, then the most common example is that of corrosion. So corrosion is a process in which the oxygen present in the air comes in contact with the surface of the metal. So when metal surface comes in contact with the air and moisture, the rusting of iron takes place. So that is one example of adsorption. Now, the most common example of adsorbent that we come across in our daily lives is silica gel. Now, silica gel refers to those small sachets of these beads which are found in new bags and new shoes. Now, the role of this silica gel is to remove the moisture present in the air so that the product remains dry and fresh. Now, silica gel is an adsorbent. It absorbs the moisture from the air. Now, what is the reason for adsorption? The reason for adsorption is by looking at this picture, you will see the difference between the molecules which are present at the surface and the molecules which is present in the bulk. The molecules which is present in the bulk is much more stable compared to the molecule which is present at the surface. The reason for that is because in the case of molecules which is present in the bulk, it is uniformly surrounded by forces, whereas in the case of the molecules which is present at the surface, the forces are not uniform around this molecule. So because of which it has some residual forces or it has some residual energies present on it. Now, because of that reason, the molecules present at the surface has higher energy and they are unstable, and because they are unstable, they tend to react with the absorbent molecules which comes in contact with it. So when these adsorbent molecules comes in contact with the molecules at the surface, it tends to react with the molecules which is present at the surface. So this adsorbent interacts with the molecules at the surface, and which results in these molecules losing its extra energy. When it loses its extra energy, it becomes stable, it will have less energy. Now the extra energy is released. Now because this extra energy is released, the process is said to be exothermic in nature. So let me write it down, exothermic. The process in which energy is released. So absorption is an exothermic process. Now, the process being exothermic in nature, now let us look at the Gibbs-free energy value of the adsorption. Now, during the adsorption process, we know that the enthalpy of absorption is negative because it releases a certain amount of energy during the absorption. That is, the reaction is said to be exothermic reaction. So delta H will be negative. And in the case of delta S, which refers to the entropy change, now entropy refers to the randomness or disorder in the molecules. Now when the molecules comes and gets absorbed on the surface of the absorbent, the randomness or the disorder decreases. Therefore delta S is also negative. So in this case, this negative and this negative, this entire thing will become positive, and delta H will be negative. Now in order for the delta G to be negative, delta H is already negative, now this is positive. Now in order for this to be negative, this has to be higher compared to T delta S. Now that can happen only when temperature is low. So only at low temperature, the delta G will be negative, which means the adsorption process is spontaneous. Now there will be a point when delta H becomes equal to T delta S, and that time the Gibbs free energy value will be 0. Now that point is called as adsorption equilibrium. So that is about the Gibbs free energy involved in the adsorption process. Now let us look at the difference between the molecules which are present at the surface before absorption and after absorption. The molecules which are present at the surface before absorption, as discussed earlier, they are unbalanced, the forces are unbalanced, they have more energy, they are unstable. Whenever a molecule is said to be unstable, they have high energy, and if they have high energy, they are said to be reactive. So that is the case before the absorption. Now after the absorption, the molecules at the surface becomes balanced, the forces are balanced, it releases extra energy, therefore it will have less energy and they become stable. So that is about the reason of absorption. Now that we know what is absorption and what is absorption, let us look at the difference between absorption and adsorption. As we know, absorption is a bulk phenomenon and adsorption is a surface phenomenon. And obviously, when you look at the concentration, in the case of absorption, the molecules are uniformly distributed throughout the body of the solid, whereas in the case of adsorption, the concentration of the absorbate is more at the surface area rather than in the bulk. And the third difference is the absorption occurs at uniform rate, whereas in the case of absorption, it is rapid in the beginning and then it slowly decreases. The reason for that is because as the absorption progresses, the surface area available for absorption is decreasing. Therefore, the rate of absorption also decreases with the decrease in the surface area. So it is said that the rate is rapid in the beginning and it becomes slower as the absorption progresses. And then absorption is said to be endothermic, whereas adsorption is said to be exothermic process, as we just discussed about it. So that is about the difference between absorption and adsorption. Now let us look at the process called sorption and desorption. The sorption is the process in which both absorption and adsorption takes place simultaneously, whereas in the case of desorption, from the name itself, you get an idea that it is the opposite of sorption, so which means you are removing the absorbed particles from the surface area. So here, let's say this is one water molecule, oxygen and 2 hydrogen atom. During the absorption, they get absorbed on the surface area of the absorbent, whereas during the desorption, it is removed from the surface area. This process of removal of the absorbed material is called as desorption. So for this, I can give you the example of the silica gel. Now, the role of silica gel, as we have discussed, is to absorb the moisture present in the air. Now, once the surface area are filled with the water molecules, it cannot further absorb the moisture. So, in order to regenerate the silica gel, it is heated. So, when you heat it, the water molecules from the surface area of the gel, silica gel, is removed. And now that process of removal of the water molecules from the surface area of the silica gel is called as desorption. So that is about sorption and desorption. Okay, I have got one more example here. Here I've taken the example of the absorption on the surface area of catalyst. The role of catalyst is to provide surface area for the reaction to take place. As you can see here, now the two reactants, they react together and it forms product. Now once the formation of the product is complete, it will leave. Here the reactant comes, one more reactant comes, these two reacts together, it forms a product. Now the product will leave. So the leaving of this product from the surface is called as desorption. Now let us look at the types of adsorption. The first type of absorption is physisorption and the second one is chemisorption. The physisorption is the type of absorption where the interaction is due to weak van der Waals forces of attraction, whereas in the case of chemisorption, the interaction is because of the formation of the chemical bond. So based on the interactions involved between the absorbate and the absorbent, absorption can be of two types. The first one is physisorption and the next one is chemisorption. Physisorption is where you have weak van der Waals forces, whereas in the case of chemisorption, a chemical bond is being formed between the absorbate and the adsorbent. Now here, this picture depicts the interaction between the absorbate and the absorbent. In the case of physical absorption, it is merely due to the van der Waals forces of attraction in between the absorbate and the adsorbent. Whereas in the case of chemical absorption, you can see that a bond is being formed between the adsorbate and the absorbent. So that is the main difference between physical absorption and chemical absorption. So physical absorption, which involves weak van der Waals forces of attraction, it can form multi-layer of absorbate on its surface, whereas in the case of chemical absorption, it forms only a monolayer because once the surface area is all occupied, it cannot further react with the second layer of the absorbate. So therefore, in the case of chemisorption, it is just one layer forming on the surface. Now, to give you an example for physisorption and chemisorption, the most common example for physisorption is the role of activated charcoal in absorbing the harmful gases. So in the case of the marks that are being used, the marks which contains activated charcoal, the role of this activated charcoal is to absorb all the harmful gases, which prevents it from entering into our body. So that is an example of physisorption where the interaction is due to weak van der Waals forces of attraction. Now in the case of chemisorption, the most common example is the rusting of iron. The rusting of iron is due to the bond formation, a chemical bond being formed between the oxygen present in the air with the metal surface. So the metal, when it comes in contact with the oxygen present in the air, there's a formation of metal oxide. Now this formation of metal oxide cannot be reverted back. Therefore, chemisorption is irreversible in nature, whereas physisorption is reversible in nature. So that is the difference between chemisorption and physisorption. Now let us look at the difference between physisorption and chemisorption. So as we just discussed, the most important difference between the two is the presence of the van der Waals forces in physisorption, whereas in the case of chemisorption, there's a presence of chemical bond formation. And the second difference is physisorption is not specific in nature, whereas chemisorption is highly specific in nature since it involves formation of chemical bond, so certain reactants has to be present for that reaction to happen. And now in the case of physisorption, it is reversible in nature, chemisorption is irreversible in nature. And in the case of physisorption, it depends upon the nature of gas. More easily liquefiable gas are absorbed easily. That is because the gases which can be easily converted to liquid have more van der Waals forces of attraction compared to others. That's why those type of gases are preferred for physisorption. And in the case of chemisorption, it also depends upon the nature of gas. Gases which can react with adsorbent show chemisorption. So because it is highly specific in nature, so only those gases which can react with the adsorbent can undergo chemisorption. Okay, now next point is the enthalpy of absorption is low in the case of physisorption, that is between 20 to 40 kilojoule per mole, whereas in the case of the chemisorption, the enthalpy of absorption is high, that is between 82 to 40 kilojoule per mole. Now from this, to define what is enthalpy of absorption, now the enthalpy of absorption refers to the amount of energy released when 1 mole of adsorbate is absorbed on the surface area of the absorbent. So in the case of physical absorption, the amount of energy released is less compared to the amount of energy released in the chemisorption. That is because in chemisorption, there's a formation of chemical bonds which are much stronger compared to the weak van der Waals forces which are present in physisorption. And then the next point of difference is low temperature is favorable for absorption. It decreases with increase of temperature in the case of physical absorption. In the case of chemisorption, high temperature is favorable for absorption. It increases with increase of temperature. So the reason for that is, in the case of chemisorption, the molecules need certain amount of activation energy for the chemisorption to take place. For the formation of the chemical bond, a certain amount of activation energy is required, which can be easily attained if the temperature is high. Therefore, high temperature is favorable for chemisorption, whereas in the case of the physical absorption, high temperature tends to dissolve the absorbate. Therefore, the low temperature is favorable for physical absorption. And the next point is no appreciable activation energy is needed. In the case of chemisorption, high activation energy is needed. And then finally, it results into multi-layers on the absorbent surface area, whereas in the case of chemisorption, it results into unimolecular layer, which can be explained with this picture. You can see that in the case of the physisorption, a multi-layer is being formed, whereas in the case of chemisorption, only a single layer of absorbate is absorbed on the surface area of the absorbent. That is because in the chemisorption, a chemical bond is being formed, because of which when the surface area are all fulfilled, it cannot further react with the next layer of the absorbate. Therefore, a single layer in the case of chemisorption, whereas in the case of physical absorption, because of the weak van der Waals forces, it can form multi-layer of absorbate. Now let us look at the last topic of today's class, that is the factors affecting absorption. The factors which affect absorption is the nature of the absorbent, the nature of the absorbate, and the temperature and the pressure. The first one, that is the nature of absorbent. Now here, whenever we talk about the nature of absorbent, you must think about the surface area available for absorption to occur. Now, if there is more surface area, more absorption can take place. If the surface area is less, then the absorption will also be less. Now that will depend upon the size of the absorbent. If the absorbents are finely divided, there will be more surface area for absorption. And also if they have a rougher surface area compared to the smooth surface area, the rougher surface area will have a more surface area for absorption compared to the smooth ones. So here it says absorption increases with increase in surface area of the absorbent. More finely divided or rougher the surface area of the absorbent, greater will be the surface area, and hence greater will be the absorption. Now this can be explained with this picture. Here I've taken the example of charcoal, the one which is in the form of a big paste and the one which is in the form of powder. The one which is in the form of powder has more surface area available for absorption, whereas in the form of this one, here only the outer surface area are available for absorption. That's why the smaller the size of the absorbent, more is the surface area available for absorption. Now next one is the comparison between the smooth surface and the rough surface. Now in the case of rough surface, all these burrows provide surface area for absorption, whereas in the case of smooth, there is no burrows, so therefore it has got less surface areas compared to the ones which has rough surface area. Now let us look at the nature of absorbate. In the case of absorption where gas is absorbed on solid, the gases which are easily liquefiable and which are highly water soluble are more absorbed compared to the others. That is because this type of gases have greater van der Waals forces of attraction. Now next one is effect of temperature. As we have discussed earlier, the effect of temperature is different in the case of physical absorption and it is different in the case of chemical absorption. So in the case of physisorption, the absorption and the increase in temperature are inversely proportional to one another. That is, it favors low temperature. So as you increase the temperature, the absorption tends to decrease. That's why you get a curve like this indicating the absorption and increase in temperature are inversely proportional to one another in the case of physical absorption. Whereas in the case of chemical absorption, the absorption first increases with the increase in temperature, but it reaches a point after which absorption decreases with the increase in temperature. That is, once the surface area are all occupied, the absorption rate decreases. So from this we can conclude that in case of physical absorption, low temperature favors absorption. If the temperatures increase, absorbent molecules get removed from the absorbent. And in the case of chemical absorption, due to the high energy of activation, the extent of absorption increases initially and decreases as the temperature increases further. So that was about the factors affecting absorption. Also, we have come to the conclusion of today's class. And thari zinda na khari chiba de do du jishina ba thamoni la surface chemistry lana khande lagi me. Then absorption lana khari rela jarwan. Absorption the absorption ni ki mala keba khari yoris. Absorption la du sambala bulk phenomenon. So example khari kire na sponge chu na lu wala china chu di sponge na lo chazan tsugi to ba dila absorption lengres bulk phenomenon. Absorption la du sambala bet na lo mazu ache surface kana dewala absorption lene. So surface chemistry the surface phenomenon nyamlo deal chigu esa ngazo chai di khare lena absorption gi kola changores ani absorption process chi yung bala ani khare changore lena absorbent ni absorbate lana molecule species ya surface kana attach chiga linge chwa dila absorbent la du sambala substance which provides the surface area tengi chwa absorption chala dila absorbent. And the name also absorption like the corrosion chungore. Now why absorption takes place later? Absorption corrosion chungore la namazo a surface kana molecule you go chwa dige unstable ways. Unstable in this samara console energy to you wache unstable high energy and dingi chawarasna kozo kare reactive ba unstable and reactive ba ta molecules shi azo bulky na ho like dita warasna kozo space stable units kare china de ko gi in force the chazan uniform che surface kan like your molecule the in force is unbalanced in this samala ko unstable chawaras ta unstable in this samala chilo ne absorb it chili this samala ko nim the lapsan react chigres react chi ne ani energy thewa jirwa odi ma tungire study absorption ke process ki nalo la energy di ma lugi yesa ko process de kare na exothermic dene ngazo types of absorption la type in a year is number the chemical absorption you the physical absorption chemical absorption the physical absorption la tedu sabala chemical absorption la du sabala chemical bond form chako physical absorption ki nalo la ani bond form chagi mewache weak van der Waals forces of attraction the any absorbent ni to go lecture differentiation the teacher then enthalpy of absorption the physical absorption and new energy new release chemical absorption energy the current ma release lecture ba then also factors affecting the absorption chawala ni factors kari ki affect chukol lecture Tango de la nature of the absorbent the gana surface area kazu ma ina absorption ya acheres that the absorption ya surface area ya ache la ko size the kazu chunga ina absorption surface area the ma ina tagana shi surface area the kazu rough ina ani surface area ma ina lecture ba then also nature of the absorbent the gas the solid ka absorption la ta sambala easily liquefiable the highly water soluble gases to the van der Waals forces of attraction in manga yu samala kunzo absorb chain lela this then also effect of temperature la tatu samala physical absorption la ni effect of temperature the condenser na kise temperature thoro tana absorption the neurodores karichin na du samala temperature thoro reduce samala molecules absorb cha sagyo chwa ko ma ko yungres desorption chai lela ba this in temperature thoro reduce samala physisorption la adsorption neurodore chemical adsorption nalo la kisi temperature de thoro tang warachina ani adsorption de yaro dores karachina na temperature thoro tang de samana ani kola activation energy ko echero audi rai lela de samana temperature thoro to de samana chemical absorption de kara yaro dores and those chine theringe zinda de to bahin so with this we are done with today's class thank you